Okay, this is just a short video, guys, talking about the practice assignment from class today, and just doing a couple of the problems and answering a couple of questions. So the first thing I wanted to do is just draw a little table about the operations, because this is what gets so confusing, and so I want to talk about it. So we have the idea of operation of the terms, or like the operation of the problem, versus what to do to the exponent. So because we have two ideas here. We have what's happening in the problem versus what you do to the exponent. So this first one, we have x to the third plus x to the third. So that operation is what? That's adding. Okay? So then what do you do to the exponents? In this case, you do nothing to the exponents. Because if you add the terms with like exponents, then, and I think, here, hold on, I'm going to write the answer. There you go, 2x to the third. So if you have like bases, like exponents, the exponents, and you're adding them, nothing changes. Now look at this next one. What's this next operation that we're doing? That's right, it's multiplication. So the problem is multiplication, okay? X to the third times x to the fourth. So I'm multiplying two terms. I'm multiplying x to the third and x to the fourth. So what do I do to the exponents? I add the exponents. So my answer is x to the seventh. Okay, the next problem is x to the 12th over x to the third. So what am I doing? I'm dividing. The two terms are being divided. So what do I do to the exponents? I subtract them. And then lastly, I have a power to a power. So that's x to the third to the fourth. That's called exponentiating, because it's taking it to an exponent to another exponent. Power to a power. So what do I do to the exponents? I multiply them and get x to the 12th. So I guess the reason I just really wanted to show you this is just talking about making sure you understand what's happening to the terms, and then what do you do to the exponents. So if you're adding the terms, then you do nothing to the exponents. If you're multiplying the terms, then you add the exponents. If you're dividing the terms, you subtract. And if you power to a power, you multiply. So making sure you understand that a little bit, you might want to write that down, or something to help you. So now let's look at some of the homework problems, and I just did a few of them. Like for the example, this first one is a length and area problem. So length times width equals area. So the length is area divided by the width. So I need to take the area divided by the width, and when I do that, I'm going to take 10x to the 6th, y to the 4th, and then divide it by the other term, the other problem, which was 5x squared y to the 12th. So 10 divided by 5 is 2. Okay, now there's 6x's on top and 2x's on bottom. So if I have 6 on top and 2 on bottom, I end up with x to the 4th. And then if I have 4 y's on top and 12 y's on bottom, then I end up with 8 y's on the bottom. So hopefully you can see that, and that makes sense. The next one I'm going to do is the volume problem. So volume equals length times width times height. So if you multiply all three of those together, so if I'm multiplying the terms, what do I do to the exponents? Add them. So 7 plus 3 plus 2 is 12, and then 2 plus 1 is 3. So let's look at the next page. And like I said, this is just there. You can see the answer key in a minute. This is just a few problems, going over a few problems. So this first problem I did is a power to a power problem. So so I have I'm sorry, not a power to a power problem. It was a like terms problem. So it was 3x to the third and 4x to the third makes 7x to the third. And the only reason I can add those is because they were like terms. Then I multiplied those same two terms and got 12x to the 6th. Hopefully you can see a difference there. And then this next one is just a combining like terms problem. The 2x and the negative 3x can be combined. So, and then next I'm distributing the negative first before I can combine like terms. So distribute the negative, then combine like terms. And then this next one, so I had addition, subtraction, and then this next one's multiplication, and it's a distribution situation. So I'm distributing the 2x to everything inside. And then the last one I did for you, this one goes two different ways. you can think about adding the exponents, or you could move the negative exponent to the denominator and then simplify the numerator and subtract. So both of them get you the same answer. That's something to think about. And then I did this bottom one where we do a power to a power, so we multiply and then simplify. So there's just a couple of problems, and then like I've been telling you, if there's any of you have questions, put a star by it or something so I know, so we can talk about it tomorrow. And then last one, I did a couple on this page. Here's a negative exponent. Remember, the negative 1 goes to everything, and then I'm going to switch them. The negative 2 goes to everything, and then whenever I switch them, so I'm going to send them to home from the numerator to the denominator, and then denominator to the numerator, and then there's going to be some simplification. So really look at that problem, because that's a very tricky one, and you will see something similar to that later, so make sure you've looked at that. Remember, anything to the 0 power is 1. That's always tough to remember. This one, I did something a little bit different. I wanted to show you, remember how we can expand this. And so this is probably the way you did these in Algebra 1. So I have 1 p, 4 q's, and 1 r in the numerator, 3 p's, 2 q's, and 1 r in the denominator. So when I start to cancel things, you can cancel like things. So I end up with 2 q's on the top and 2 p's on the bottom. So just for that one right there. So that hope that makes sense of how that canceling works. And it's just a really visual way to figure out the answer. And then remember this, the negative 10 divided by negative 5 is just the way you've always done it. So negative 10 divided by negative 5 has always been 2. Okay? So those are just a few problems. The full answer key is on Edmodo as well. And tomorrow we're going to play a game in class and answer questions. So I hope that you watch this for just a couple of minutes and are ready with questions tomorrow and are learning exponents. So great job.